SN7442 ANIC, 4-line BCD to 10-line decimal decoder IC. We will see its function and we will see how it works and how to test it. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. Basically, this IC is TTL IC, transistor logic IC. It receives 4-bit BCD code, binary coded decimal, and it converts that code into decimal 10-bit output. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are decimal numbers because these numbers start from 0 to 9. When these numbers are coded into binary format, that is called BCD. Because in digital electronics there are two conditions: 0 or logic 1. 0 is 0 volt and output of this IC high is 5 volt or 3.5 volt. When these numbers are coded into BCD, 0, that means there is 0 volt. 1, that means logic 1. In digital there are just only two conditions. When there is 2, that is 1, 0. Now it is not 10, it is 1, 0. That is code BCD decimal. When any digital IC will send 2-line data, one is high, second is low, there is binary weight. That time it will be considered 1, 0 is equal to decimal 2, decimal 3, 1, 1, 4, 1, 0, 0, 5, 1, 0, 1, 6, 1, 1, 0, 7. When 3 lines are high, that are called all 3-bit binary is high, that code is 7 decimal. 8. Now these 3 will convert to 0, 1, 0, 0, 0. 9. 1, 0, 0, 1. So it is BCD, binary coded decimal. 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1. So when we have 4-line data, that is called 8421 binary weight. 8421 code or BCD code. When we have 4-line data, 1, 2, 3, 4. These 4 are inputs, pin number 15, 14, 13, 12. Then we have 10 decimal outputs. Here we will provide code equal to that BCD code, respective output will active. A, B, C, D. A, B, C, D. Like this. So this IC is basically computer code or BCD code to decimal decoder. It is normally used to select different address lines. To generate BCD code, in last video I shared this pattern generator. You can make this pattern generator very easily. You can watch the video number on your screen. Let's make this circuit. I placed this IC to project board. Here is index mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Pin number 16 will go to positive supply. Pin number 8 will be connected to low side, ground. Pin number 8 connected to ground. Pin number 16 to positive 5 volt. 4.75 to 5.25 volt. Nominal value 5 volts. I will use this test pattern generator for TTL ICs which I made in my last video. You can make it simply using dip switches and resistors. For CMOS you will use 10K resistor. For TTL ICs 4.7K or 3.3K or 2.2K resistor is excellent. I will connect this pattern generator positive to VCC and ground pin to common. Low side bit will be connected to A pin, that is pin number 15. B output will be connected to pin number 14. Then C, 13, 12. 4 line inputs. Its output is active low output, inverted output, because in its output there is inverter. So inverted output. To see its output visually, we will use LEDs. Because its output is active low, I will use LED anode to VCC, cathode. You can use 330 ohm resistor, you can use 560, but I am using 1K resistor to minimize its power dissipation, because maximum 16 milliampere from one channel can be taken out. So 1K resistor, the LED will provide dim light, but that is enough to see the result. Anode, long lead to the positive side. 1K resistor to the cathode. Resistor second side will be connected to first output, that is output number 0, that is equal to decimal 0, and pin number 1. This is pin number 1. Second output. The same way 1K resistor second end to decimal 1 output, that is from pin number 2. Third, pin number 3, that is basically decimal 2. Pin number 4. Pin number 5. Pin number 6. Pin number 7. Then pin number 8. 8 is ground. Next output from pin number 9. Pin number 10. This is the last LED number 10. That is equal to decimal 9. Because in decimal outputs, the outputs are considered from 0 to 9. That are total 10 digits. This is pin number 11. When we have BCD input 0, 0, 0, when all input switches, data switches are 0, first LED, that is decimal 0, is high. Because LED anode is connected to positive VCC, when this output is low, this LED is bright. If I will turn on the first bit high, that is 0001, that is 1, that is equal to decimal 1, output LED decimal 1, that is LED number 2, that is now illuminated. Now if I will connect bit number 2 high, that is 0010, this LED is on. Last two bits are high, 0011, output decimal number 3 is on. If it is 0100, that is equal to decimal 4, this LED is on. 0, 1, 2, 3, 4. 0101, that is decimal 5. This LED is on now. 0110. 110 binary coded decimal 110 is equal to decimal 6. So it is decimal 6. This is low, this is high, high, high. 3 bits are high, that is decimal 7. 0, 1, 2, 3, 4, 5, 6, 7. Output number 7 is on. If you will turn on this bit high, the other are low, that is equal to decimal 8, BCD 8, this LED is on. 1001, this bit high and this bit high. Last output is enabled. This IC receives BCD code and converts into specific decimal location, because maximum 9 locations can be interpreted from this IC. So maximum 1001 is possible address setting. If I will turn on more bits high, let's suppose 8 plus 1 9, if I will turn on one more, all outputs will disabled because we turned on invalid location. From 00 to 1001, this BCD code can be provided to this IC. Then it will convert that 4-line BCD code into 10 decimal locations. Here I injected manual code. If you have external BCD code, that is automated code, that time this IC will behave approximately similar to CD4017. CD4017 receives binary input and enables different decimal locations based on the number of bits. Here we are injecting manual BCD code. If we have automated, then it will work automatically. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.